Today, before we resume the electromechanical impedance technique, I want to give you a demo of another program. So this program was written by MTech students who did their MTech project in the field of damage detection using global vibration techniques. So I am introducing this program to you now deliberately. I did not introduce you this program before because I wanted to give you first-hand experience how tedious the method of peak picking is. So now I am today demonstrating you this program, and I'll also share it with you tonight. So you can use now this program with your data. The data you are now analyzing for mode shape extraction. So you can use this program also for that. So basically this program, what it does it that we consider a beam type structure, 1D structure, and we define how many sensors we have. So we are assuming that there is no sensor at the two nodes, and in between we have certain number of sensors. So that defines how many parts the beam is divided. So I am just running this program, and before running the program, you can basically go through the readme file. So along with the program, I will give you the readme file. So the programs have several versions. One version is that it can do with the column, that is column of the FRF matrix is there, and you can obtain the mode shape using a column, or alternatively you can use the row. So column basically means that we are varying the location of the force and our measurement is at one point, and the row, that is the row, and column means that we are basically exciting at one point and we are concurrently measuring the response at multiple points. So this program I am just running. So my advice would be that you first master the program with the single hit approach. Single hit means that we are applying force at one point and we are doing the simultaneous measurements that you can use for first mastering the program, because the data is simple. It has only two files for this purpose, that when we are exciting one point and we are obtaining all the measurements in a single file, so that makes it simple. And once you master it, then you can have this program for running in the other mode. So there are sample data within this. Okay, so I'm just running the program. So I hope my screen is visible to everyone.
Yes.
Yes, sir.
Okay, so this MATLAB dialog box has opened and it asks some of the important information about the structure. So this program is only for the beams. So it asks for the length. So for this particular beam, the length was 2 meters. So the beam was different from what you see in the lab. The beam on which you have done the experiment, that is 3+ meters, means more than 3 meters in length, but the earlier beam was different and smaller cross section. Then it asks the number of sensors. We have 7 sensors. Then it asks for the channel in which the force measurement is recorded. We have to specify that. Then it asks for the time interval, that is 1 millisecond. And then it asks for the total number of readings. So that is 2500. So all the input files, they are there in the folder which I'll be sharing, and it may happen that some of the files, they are in the earlier version of Excel. So in case you are getting a runtime error, all you have to do is that you open those files in Excel and save them with another name. So some of you might get runtime error. So that is the way, if in case you encounter, because the files are earlier versions. Okay, so I'm pressing OK. Now it gives us the option, what do you want to use? You want to use the absolute part, or the imaginary part, or the real part. So absolute part, we have seen that it's very good for identifying the peaks, the natural frequency. So you can in fact run it for absolute also, but I am running it for directly for the real part. You can also run it for the imaginary part, or you can first run for the absolute, so that you get the peaks. With the absolute data, it's easy to identify the peaks. Okay, so I am here giving the input as 3. Then it asks whether it's the single hit approach or the multiple hit approach. So single hit, multiple hit, you can very easily relate. Single hit means we are applying force at one point, and in the single go we are acquiring all the data from all sensors. So I'm entering here 1. Sorry, I have to enter 1 here. Now it asks the name of the Excel file. So are you now able to see the graph?
Yes, sir.
Okay, so you are able to see the graph, and you would now agree with me that there is a significant noise. Noise is there, right?
Yes, sir.
But then we also have a good thing that our signal is also quite significant. So signal to noise ratio, at least in the beginning part, is not that bad. But we have to carefully select the data. So we have to very carefully select the data. So for this, basically I am selecting the data. So there is a guideline also here. So I will be selecting the data. So just hold on. So now we see here where is the point of the application of the force. So this window is most important. So I am choosing somewhere here. So 200 to 600 I am choosing. So I have entered here the, so this is not the absolute time, it's in terms of the readings. So there are 2500 readings. So this is for 2.5 seconds, because our sampling interval is 0.001 millisecond. Sorry, 0.001 second or 1 millisecond. So that makes it 2.5 seconds. So here we have to enter the starting and the ending points in terms of the data number. So 200 to 600. So 401 data points I have chosen. So now similarly it asks for the force also. So force also we have to be same. If you are choosing different times for the force, then you will have difficulty. So choose exactly same. So 200 to 600. So now it has done the plotting. So now we have to identify the peak. So the data is noisy, so we see one peak here, 34.9127. Do you agree? 34.9127, we are seeing a peak. So now it's a picking method, so it is basically interactive in nature. It's asking the user that you want to try. So we have found this peak, so let's try at this peak, and there is one more peak before this, but I am choosing this one. So you have option, you can choose others also. So the value is 34.9127. So let me enter here 34.9127. okay. Now it asks whether the sensors are placed equally or not. So in our case, the sensors are all uniformly placed, so we enter 1. So now it has plotted something. Now can you identify which mode shape is this?
Second.
Second mode shape.
Yes.
Sorry, second mode.
This is the second mode shape. So second mode shape is identified. So that's how we have to use the peak picking method. So just like I have here chosen the second mode shape, similarly you can use this program interactively with your data, and you can obtain the first mode shape also. So now it says if you yes, someone is speaking.
First peak, right?
We have not chosen the first peak. We have chosen peak after the first. We did not zoom that region. So what I would suggest to you is that you can first run this program with the absolute values. Then you will be able to see exactly the modes, and then you rerun this program again, so that you can plot at various frequencies, and you would be able to get it. So this is the second mode shape I am getting here. So now it asks you want to proceed further for damage analysis, then enter 1. If you want to stop here, then enter 2. So I choose that. Let me do the damage analysis. I enter here now 1. Now it asks me how many sensors. That is exactly same. And it asked me the Excel file name for the damaged case, so that is SD. And it will do the same thing now. So now for the damaged case, we see the noise is much smaller. Do you agree?
Yes, sir.
Yes, sir.
So we will choose the same timing. Now this is a damaged beam, so its frequency will now change. And similarly, this is for the force plot, and this also we choose. Alright, so now let's choose the frequency, because our undamaged frequency was how much? 34 Hertz. It is 79, so this is not that. And let's go further. 47, no. 44, no. So let us do a zoom. Yeah, 24.9377 is something. So let's enter this 24.9377. Because finally we have to again ascertain.
Sir, it's 24.937.
Yes. Have I entered correctly? Check from my screen. Is it correct?
Yes.
But is it the
Sir,
same?
why it is Sir, why it is chosen as 24.9377?
See, right now we have to ascertain that this is the second mode shape in the case of the damaged beam. So our choice is correct or not, we'll come to know after we get the plot. Okay. See, what was the frequency in the case of the undamaged beam? It was 34 something. And you see here the major peak, this is how much? See, after damage the frequency cannot increase, it will reduce only. So if you see some of the peaks, they were 79, 44 something. So we ruled them out and we have chosen 24.9377. But this is correct or not, we have to see the plot first. Okay. Again it asks if the sensors are equally placed or not. We say yes, 1. So now what you find, is it correct or not?
Yes, sir. It's second mode
Yes.
shape only.
Second mode shape.
So it's the second mode shape.
Sir, this is second.
The second mode shape, you might be thinking how this is coming out so quickly, because we have before showing this to your to the class, I have done few trials beforehand. Okay, so that means our choice of 24 point something something, that was correct. It corresponding to the second mode shape. All right. Now it says to continue and see the bar graph, enter 1. So what you see here, the second plot, it shows the element number. So it has divided the beam into 8 elements because there are 7 sensors. And what we find is that which element is damaged? 6th element is damaged because 6th element has the highest value of the change of curvature. So basically these mode shapes, they are the curvature mode shapes, and here the 6th element has the maximum value. So this is the damage element. The top figure is basically with respect to the nodes. So first we have plotted with respect to the nodes, and then we have converted it into element data. How we have done that? So we are just seeing what are the nodes to the left of the element, what is the node number to the left of the element, and the node number to the right of the element, and we average that. So we assign that value to the element. So the red one is for the element, so we find 6th element is damaged. Okay. And then it says to see the beam and different elements, enter 1. So let's do that. Yeah, this is the beam and these are the various elements. Okay, so I will be giving this program, so this will make your work easier. I deliberately did not introduce this program earlier. Now I will give this program to you and you can try with your own data. Your data is like multiple hits, so you have different data sets. So what you have to do is you can use this program for that with the multiple files, or you can convert that data, because we know from the symmetry of the mode shapes, you can convert that the row data into the column data also, and you can make single files, so that is also possible. Okay, so whichever way you want, you can run the program. So I hope this demonstration is clear to everyone, but it makes our life easier that we don't have to stretch our eyes too much in the Excel. All right.
Yes,
I will also take 5 minutes today.
Yes, please.
Anytime.
Now you see here, this is the two. These are the two mode shapes here. The damaged and the undamaged, they are being compared. Okay, I am now just exiting the program. Yeah. So I'm just closing this MATLAB box. Yes, Dr. Dhawan, you want to say something? Your camera, you have to change the position of the camera. Yes.
I am there and my voice is audible.
Yes, your voice is audible. Please continue.
Thank you. The two important things which I would like to share. One is the visit to the Signature Bridge. Today, I personally talked to the chief project manager, who is the chief engineer deputation from CBOD. His name is Mr. Pawan Kumar. People keep on changing. The present man is Mr. Pawan Kumar. I have already given his telephone number to Professor Bala. So, as decided that immediately after Holi, you can plan a visit, and then before that, any time on Monday, Tuesday, Professor Bala will talk to him and fix up the date and time. And then for that date and time, he will fix some officer who is in charge of this. We'll go and see the bridge, and then you can see that where they have installed the sensors, and then you can put the question to them how they are making use of those sensors and finding the damages. So, and then when you go, you should just again make a link so that we even don't go can have a look of the your visit as well as the questionnaire that you are going to ask the person who are working on the Signature Bridge. Secondly, I had already told Major Anuj that for your visit to the flyover near IIT campus, near the hostel, you can make a program, and then at your convenient date, you can go have whatever you want to do. So these are the two things assigned to me, and now the ball is in your court. And anything problem that you come across, please don't hesitate in telling me. I can again talk to these persons. This is what I want to say. Please continue, Bala.
So thank you, Dr. Dhawans. So we are very thankful to Dr. Dhawan. He has arranged, first of all, our visit to Signature Bridge. So we have to now choose a date. So on Monday, I think we can decide the date for the visit after the Holi, and then we can be in touch with Mr. Pawan so that we can visit. So basically, those who are from the NCR region, you can reach directly to the venue of the Signature Bridge, and those who are from the within the hostel areas will let you know how to reach there. So basically, we are not formally organizing a trip per se. Like earlier years, we used to book a bus, and the bus used to take all the students to the venue, and we used to spend 3-4 hours over there and come back. But this time what we are doing it, that those who are out of town, for those people the visit is through online link, and those who are here, they can go there. And those who are here means that people who are in the campus or people who are in the NCR region. So at least those who are in the NCR region but not in the campus, you should also not miss this out for your own good. And it's also apparent that a lot of you are joining the hostels and coming for the onboarding based on what directions have been given by the dean. But in our case, we'll keep both the methods open. If you are not coming, and if you are still in your homes, then you can be through our online medium. You can still watch it. So I'll be in touch with Major Anuj, and you can discuss the dates etc. with Major Anuj, and then I'll finalize with him on Monday.
Then Major Anuj, another thing that you guys, after finishing the program and fix time, you should all assemble in his office, where somebody will just explain to you about the bridge and the other sensors, and then you can go, all of you together, along with the officers, take you, then go and have a look of the thing, take photographs, then every individual has to submit a report on that.
Okay, fine. So thank you very much,
That's all.
Dr. Dhawan.